We have function notation again. The graph of g of x is the image of f of x. So the red graph f of x is the original graph, and the blue graph is the image graph. Corresponding points are labeled. Write, then verify an equation for the blue graph in terms of the function f. So this is working backwards. We have both graphs, but not the equation. Usually we start with the equation, do our transformations, and then draw our final graph. Now we have to work backwards. So what are we given? We're given 2 points on our original graph. We have the points, and I'm going to label them A, which started at 0, 8, and B, which started at 2, -8. And some transformations happened, and we ended up with the point A at -2, 0, and they labeled that with an A prime, and point B at 0, -8, B prime. And we have to figure out, hello. So we had an example similar to this in section 3.3 that mental math, you could just see what you needed to do. This one's a little bit harder because 2 things happen, and you could guess and check for a long time and find nothing that really works. So the strategy that I introduced the last time we're going to use again. And that strategy was looking at original horizontal distances and what happens to new horizontal distances. So if I go from A to B, oh, and I'll do that in red because that's my red graph. I'll write it in red. If I go from A to B on my red graph, the horizontal distance from A to B is 2. If I then look at my blue graph from A to B, it's also 2. Was there a change? No. Technically, this means you have to multiply your x values by 1, but I'm not even going to write that above the arrow here because it doesn't do anything. But when we look at our vertical distances, from A to B, we are going down 16. So I'll represent that as a -16. And on our blue graph, from A prime to B prime, we're going down 8. How do I get from 16 to 8? It's telling my y values have to have been multiplied by a half. And I can now go above this arrow and add that in. If I multiply my y values by half, I can fill in these points now. I know it would go to 0, 4 and 2, -4. The next thing I have to ask, is there a way to translate? I need to go from 0 to -2 and 2 to 0. Horizontally, that would make me go 2 to the left. That would match up perfect. And if I look at my y coordinates, I need to go from 4 to 0. So that means I'd have to go down 4. Does down 4 work for the other one as well? Well, I go from 0 to -2, so I'm going 2 to the left. And I'm going from 2 to 0, because we're always going this way. That'll be 2 to the left. And here, from 4 to 0 and -4 to -8, I'd have to go 4 down. And now that I've filled those things above the arrows, I'm able to write the equation in terms of the function f. I can say that my blue graph, g of x, is going to equal y by a half. That happens outside of the function. 1/2 first. 2 to the left, that will happen inside the function as x plus 2, and 4 down happens outside of the function as minus 4. So we set things up, but we have to do an analysis to figure out what happened with our stretches and compressions both horizontally and vertically first, and then once you fill that in, everything else is easy. Okay? So I don't know if afterwards, if you look at your notes afterwards and you read this, you're going to be confused because you're going to see this and think you did that first. So maybe you want to label that we did this first. And after doing that, you got those values second, which allowed you to figure out these points third, which allowed you to figure out this fourth. Especially when you're working backwards, when you're undoing something. Working forwards, the steps normally happen that you do this first, this second, this third, and get your answer. But working backwards, you're kind of dealing with a whole bunch of different situations. It's not as linear. And so what we did first was this and labeled the original points. We labeled where those points ended up. And then filled in everything afterwards. Did we answer all of the question? This is a very good skill to have in a math class, is once you're done a question, to read the question over again, just to make sure there was, did they ask for domain and range? No. Write an equation. It says then verify. So verifying it would mean actually start with these original points and do this to see if it worked, which we can see just by looking from left to right that it does work. So everything that was asked for has been done. Question for practice on this one is number 9.